All right, why don't we go ahead and get started. So, hey everybody, my name is Joe Fernandes. This is the OpenShift Ask the Expert session. So, I lead the OpenShift business here at Red Hat. I'm the general manager for hybrid platforms, which includes OpenShift, OpenStack, and our virtualization and runtimes business. I'm joined by our two product management leaders. I'll let Andy and Mike go ahead.
Hi, so Andy Cathrow, I look after our managed services, so Rosa, AWO, and OpenShift Dedicated.
And Mike Barrett, I'm sorry I'm playing peekaboo with this side of the room behind this podium, but I look after the core CNCF and Kubernetes investments.
Cool. So this is an interactive session. It's good for us because we don't have to build slides. It's good for you because we don't have to. You get to ask exactly what you want, and we have to answer. So hopefully there's a lot of questions. So we're just gonna kick things off, talk about a couple of some of the announcements that we've made, and then literally just feel free to raise your hand and so forth. So, but I'll start with Andy. So one of the things we announced today was ROSA with hosted control planes, a preview. I'm sure not everybody knows what that means. Can you want to talk about what that is and why we did it and
Great.
the benefits?
So there's a project called HyperShift, and any of my team or marketing, if you say HyperShift, not hosted control planes, it's a $1 swear jar donation. Mm-hmm. That's actually helped fund a lot of the engineering work. So what is the HyperShift project, which we're now productizing as hosted control planes? If you think about a traditional OpenShift deployment, you have 3 control plane nodes. We typically add 2 infrastructure nodes, and then it's your workers. So before you've even deployed a worker node, you're paying something like, I don't know, $9,000 to $13,000 per year for, in the case of Rosa, AWS infrastructure, or on Azure, or on Google. And that's just to run the control plane before your workloads. So the first problem is cost, right, that you're incurring. The second challenge, from my perspective, is running a managed service is it's in your account, which means, firstly, I need to get network access into your account. I don't want that. You don't want that. The second thing is if it's in your account, you can change it. And we see lots of accidental deletions of what's this like a large VM. Let's just kill it and goodbye control plane. And also, we need more permissions once we're in your account. So with hosted control planes, we move the control plane into a service account. So right away, you're no longer paying whatever, $10,000, $12,000, $13,000 to the cloud provider. We have less access to your network. We require less permissions. Provisioning time goes down to around 5 to 7 minutes for a cluster, compared to 40, 45 minutes on average for managed services. And then it enables some more features. So it was designed to be managed. So rather than taking traditional OpenShift and putting our management SREs around it, it was designed from day one to be managed. Right? So some good examples of features that enables. The first one is upgrades. Right? Everybody loves upgrades. Everybody loves 2 o'clock on a Saturday morning doing an upgrade. Even with a managed service, well, we do that for you. Right? You schedule, I want this time and this release, and we run the upgrade. Your app teams are still there. They're waiting for the platform to finish. They're going to validate the apps, and they go back to bed. So one of the great features with hosted control planes is you can upgrade the control plane and the worker node pools separately. So you can say, I'm going to schedule the control plane upgrade for, let's call it 10 a.m. Right? Have my coffee, non-destructive control plane upgrade. The worker node pools, you could upgrade individually. One of the cool features is you could say, well, it was a 412 cluster. I'll just upgrade it to 413 on the control plane. I'll create a new worker node pool with 413. I won't upgrade those nodes. I'll just deploy my workload to that pool, and I'll kill those nodes. So we're interested to see the usage patterns that we see with our customers, but I think we're not going to be seeing many upgrades of worker nodes anymore. We're going to see new deployments during working hours. Right? So this is one example of the features. For more, we've got a session that's been recorded. We've got a blog. Come to the booth to give you a demo. But I'm going to take over the whole session with that. So.
Yeah. So this is ROSA with hosted control planes. Check out the blog. Like Andy said, come to sessions. It's in preview. You can get access to it. It's new to ROSA. It's not actually new to Red Hat or OpenShift. It actually, the original technology was built by IBM for how that's how they run the OpenShift on IBM Cloud service. We helped them evolve that to 4X, open source the code, and now bringing it to our other services. So it'll be available in Arrow, Azure, Red Hat OpenShift next, OpenShift Dedicated after that. And it's already, for the self-managed customers, it's already available in preview, and will be something that you can deploy in your data center. So you can continue on with dedicated clusters, dedicated control planes, or take advantage of essentially this new deployment model. So, so Mike, with that, so I know you've been working to support what Andy's rolling out in ROSA, but Mike has Andy has the PMs for all of our OpenShift cloud services. Mike has the PMs for all of core OpenShift platform itself. So we announced also OpenShift 4.13. So tell me, what are you excited about?
4.13 came out this month. The big items, obviously Kubernetes goes to 126, but we also moved to RHEL 9. So previously that RHEL Core OS was 8 in OpenShift 4. So this is a major upswing of the operating system. That opens the door to C groups v2, RPM layering, so you can now put drivers into that RCOS image instead of slamming everything into containers. C run, so this new runtime that's compiled in C that's more lightweight and efficient than Go. So that opens the door to more capacity on the nodes itself. Other cool stuff, I would say, the rest of the stack. So pipelines got FIPS compliance. Service mesh now supports Cert Manager. So a lot of quality stuff came out. ACM's looking at namespace right sizing. So that's a great feature to check out.
Yeah, so when you get an OpenShift release, as Mike said, we bumped the version of Kubernetes, bring the core platform out in 4.13, but then there's releases of all of our layered operator services. They're all based on different upstreams like Tecton, like Argo CD, like Istio, and so forth. But we try to move that all as one platform because we know for many of you, you're deploying all of them or a substantial number of those. And so check that out as well as also the layered product announcements. So I could ask all the questions, but this is for you all. If anybody has questions, just raise your hand and we'll call you out. And go ahead.
Yeah, go ahead.
Yeah.
Short question about the Kubernetes CNI. You recently introduced that as the new default for the OVN for OpenShift. And my question is related to ours. So it's 1 to 2 years ours cluster in production. So will there be any, the migration will bring some downtime to my clusters, changing the OVN for OpenShift? Will there any kind of deprecation come in the next time for the old setup, like there is Kubernetes OVN not the default?
Yeah. So just to give context, so OVS is the default SDN that comes with OpenShift. It's what we use in our self-managed, what we use on our hosted services. OVN, as many of you know, is the evolution of that. So I guess starting with you, what plans for OVN and Arrow, and then I guess cloud services generally?
OVN is default for us from 4.11 onwards in ROSA and Arrow and OpenShift dedicated. In terms of deprecation, in terms of a path from OVS to OVN, one will be provided. That's not going to be a downtime path. It'll be part of an upgrade. Until we have that ready, there's going to be no forced downtime for the clusters. Right? There'll be, so we were running these clusters for a long time already. That's going to continue to be supported. And we have plans, and this is Mike's team. I get to stand on the shoulders of giants over here, but the team is working on what that migration path is. But the goal is like a non-disruptive migration as part of an upgrade.
You want to talk about OVS lifecycle?
Yeah, in the core base itself, engineering they would very much so like to remove that off now that we moved to the default to OVN. So we're trying to pick the right time, the right release to announce. We always, whenever we prepare to remove something, we let you know one release in advance. So you will definitely have like a buffer of at least 6 months to realize that it is being removed. But we don't have that targeted yet on when it would be actually removed.
Right now, there's not actually a plan to deprecate OVS. We want to see folks move. We want to see kind of success. But the key thing is non-disruptive, and then having sort of a good amount of the base moved, and then making the decision. We may carry it for multiple years, depending on how that rolls out. But that's kind of where we're at. So.
And we see, because we're running a managed fleet, we get to see that day to day, right? So then a lot of decisions that we make are based on the SLOs and SLIs that we have from that managed fleet, right? So again, it's not going to be an arbitrary move. It's going to be moved based on our comfort with the platform, what we're seeing in production, and our customers' needs. So no rush, but it will happen.
Go ahead.
Okay. You said ACM right sizing in 4.13. If you could elaborate a bit on that. And then the reason I'm asking
asking is because I have the issue that many of my customers, I drive a platform at my company. Many of my customers, they request way too much resources when they deploy their applications. That's a very big issue for me to try to drive that down.
Yeah. Yeah, so right sizing is in dev preview in 4.13. It'll probably hit in GA quality, I would say 4.15, which would be our first release of Q1 next year. But what it's doing is it's taking the Prometheus information and it's zeroing in on the namespaces. And it looks at all the pods running in the namespace, and it will identify which namespaces, these are projects, are fat and which ones have more headroom. And it'll point that out to you in a dashboard.
And
So,
the bump out.
And it also forces our customers, our users to thin
Yeah, I mean, the sky's the limits on what you want to trigger off of something it realizes. So you could, have a GitOps or an Ansible playbook or whatever you want to trigger come off of that awareness.
So ACM is pulling information from the clusters, in this case through Prometheus, and going to give you this information on the sizing of those pods to namespaces. But what we did is integrated ACM with Ansible, similar to what you saw with Insights in the demo today, right? Like, so now that you have information, do you want to drive an automated remediation through something like Ansible to push stuff out, or through some of the automation of that GitOps or some other means and so forth, and that would be done by changing the CPU limits, right? Like
the request and
the request and limits of which you could already do today, but obviously having the right information and being able to do it at scale, that's kind of what this feature is about. So I encourage you to. Actually, with all our previews, we love it when folks are willing to experiment with some of the new features early, give us feedback and stuff, and that's why we usually carry things a couple of releases before we declare GA, because we want to make sure that it's actually doing what you need it to do. You had a comment.
I was just going to add, one way to drive behavior is chargeback, right? Starting with the visibility, what your customers see, what the utilization is. Even if you never do the chargeback, the showback is powerful. Right, and then you add the enforcement later.
Yeah, and for that, we do have a cost management
with
service.
Insights, exactly.
Yeah, with Insights, yeah. So at cloud.redhat.com, if you check out the cost management module in Insight, that's another path. It's different from, it's different, but using similar information, right? Prometheus metrics to inform, how much is being consumed across the cluster, who's consuming it, and then, like I said, even if you don't directly bill your application teams, just sending a report to those teams around, like, this is how much you're using and how much that's costing us, and sometimes that itself drives better behavior around.
Educate, then enforce.
Exactly. Go ahead.
Can we ask a question about ODM?
Yeah.
So my question is, why is OpenShift only support one serial storage inside ODM? Kind of limiting what we can do with it. So is there any specific reason why?
Only support what?
No CPU storage, right? You only support one pool of storage. Let's say we have NVMe drive.
Okay.
It only supports one. You cannot have SATA drive, NVMe drive.
Yeah. So I don't have the specifics, but one, I think most folks know, what we ended up doing is we actually combined the ODF engineering team with the IBM storage team, largely because we just weren't able to invest enough in ODF, in Ceph, to drive some of the features that you wanted. The way we worked it out is we're still selling and renewing and expanding ODF, so if you're purchasing that through Red Hat, you continue to do that. We have frontline support, but with the engineering teams merged, there's a lot more investment because they're part of a much bigger storage engineering effort. I know there's some stuff on NVMe work. I don't have the specifics. I don't know.
Yeah, I don't either.
We'd have to follow up, maybe give us your info afterwards. We can connect with our product leaders there. I just don't have the.
Supporting only one tier of storage on one cluster, only one use case you can support.
Yeah.
At some point, you have to create multiple clusters to support it.
Yeah, I thought we could do storage service tiers now instead. But, all right. Sorry about that. Any other questions? Yeah, in the back.
Yes, I have a question. Like,
Prometheus built in OpenShift.
So this is monitoring OpenShift from external.
Yeah, I mean, you should be able to monitor OpenShift, like bring your own Grafana. Are you referring to a managed service like configuration that you don't have control over?
Yeah, so I mean, in terms of getting access to the metrics, like that's how we do it for customers that have telemetry enabled. We have Prometheus in the cluster sending us metrics, and then we use our own dashboards to monitor it. That's also the integration into ACM. So we've integrated monitoring into ACM to do that. We aren't shipping the Grafana binary anymore, but you could still use community Grafana to access it. But there are. You want to talk about the ACM monitoring integration?
Grafana is still available through ACM, so you can still get it from Red Hat if you have an ACM license. We decided to move everything that we were doing by default in the core web browser out of Grafana into that web browser. So there isn't a single thing that we were providing in Grafana that you don't have in the web console now. But you should be successful in walking up to any self-managed OpenShift and being able to interact with it with your own Grafana.
Or managed, yeah. You should be able to scrape.
And
The problem was getting the metric from the targets in OpenShift, particularly the target in HTTPS. It was very hard to get that.
and your clusters are in the data center.
Out of OpenShift, get that metric out of OpenShift from external Prometheus.
Okay. But when you say external, are they both in your data center, or do you have clusters in the public cloud and then?
Same data center, but between OpenShift and that Prometheus, that external Prometheus, there is a firewall.
Okay.
Okay.
You can do a remote write
Yeah.
configuration, so ship that data off OpenShift to another Prometheus instance, for example.
Yeah. I mean, I know that's, the ACM monitoring aggregation is, I'm sure we have customers configure that. So I would say that should work and stuff. We just need to probably, I don't know if you have a ticket open, we can get the info. If not, we can kind of work to get.
So it sounds like you want to take one Prometheus that we're providing and forward to another Prometheus. You're not attaching Grafana to ours. Okay. So I think if you want the step-by-step on how to do it, just go to the ACM user documentation and word search for Thanos, and you'll hit the right chapters on how we set up our forwarding for our Prometheus to the ACM Prometheus. And you can use those same steps to go to yours.
Yeah, Thanos is the open source project for the Prometheus aggregation that we use, but those instructions would be applicable even if you aren't using ACM. So, cool.
Yeah. Yeah. So you're doing the right things. So thank you for doing the right things.
Good of you at Bash. I kid.
In terms of the stuff that's happening in this area of the product, we did quite a bit of. Yeah. So there's a pretty cool insights project that got started through IBM Research, and what it was trying to do was look at the telemetry coming back from all the connected clusters in the world, and trying to see if there were any signals that we weren't seeing on the ones that failed to upgrade. And so they created these algorithms, and now you can go to, I think, cloud.redhat.com today, and there's a new section under your probability of success on a cluster for an upgrade. And it'll dump out the things you should look at, like this operator's in degraded mode, get it out of degraded mode before you run, things of that nature. We also, in I believe 4.12, started down a path of putting checkpoints in. So we wanted to create a user experience for our EUS releases where you could pause the workers, segment them away from the control plane, upgrade the control plane, and then do the workers so you only reboot the workers once instead of twice. Yeah. So from that work, we realized that we should have more checkpoints that you were watching for, like where are you going? And so we have a project that we're trying to put in and vocalize those checkpoints that, yeah, you passed this, back to that main pane of glass where you're seeing the upgrade graph. So we're trying to do work to get into that.
I think at the end of the day, our goal would be something along the lines of, we'll do everything through an API, but, you know, we have an API kicking this off, and then every periodically just going in and saying, where are you? What are you up to?
Yeah.
And then we have front-end guys who check and watch what's going on as it's happening.
Yeah.
And they do the troubleshooting or escalation after.
Yeah. So we're trying to codify that, but what you're doing today is the best way to do it. Yeah.
Other questions? Go ahead.
Can you give a little more information about HyperShift? I'm more interested on the disconnected side because most of our clusters are disconnected. I know there's, you can use ZTP, zero touch provisioning, from ACM with site configs, I think. Can you maybe elaborate more on how you would set up something like that, or what's the best way to go about it?
So for those who don't know, we have this zero-touch provisioning blueprint that we put out, and what it tries to do is combine a couple projects together. The main one that it's trying to drive is this metal cubed project, which is our redfish integration, where it's asking the bare metal to come up. Most likely, this is always bare metal. Is yours bare metal? Okay. And we created another project called SIM, and SIM is like an inventory of all those service processors that you put your IP address in so it can talk to redfish and manipulate that. Together, that with what's called assistant installer, which is creating an ISO image with some answers baked into the ISO image. So when those servers boot up, they find each other and form a cluster. So combining those three together, we have this zero-touch provisioning for bare metal. How HyperShift will come into that is, it's mainly an integration with OCP virt. So if you wanted to have your pods on the bare metal, and then you wanted to carve virtual machines out of that as people request clusters. So now you have the management cluster with all the namespaces, holding the pods for all the control planes that people are asking for. How do you give those cluster request machines? So you can either give it a bare metal machine through the metal cubed, or most likely you're going to do an OCP virt call and give them a virtual machine from the bare metal.
Through like the APIs like Sushi or something like that? Like that, which emulates the bare metal for VMs? Or?
No, it will just be a straight bare metal node that it adds, or it will be a straight virtual machine from OCP virt.
And then from a disconnected perspective, it's the same, you have to mirror all the contents into a registry that sees the disconnected environments, and the only difference is the worker node, like the control planes are pods working on a management cluster, and then the worker nodes are VMs or machines basically coming up as people request clusters.
And if you did want a bare metal worker, it will automate a assisted install ISO boot for that worker. That's what it's going to go down.
We're very quick in the open space, looking some suggestion on how we would approach three different types of consumers. We have public, trusted, vendor, and internal users. So we would have three different types of application. One is internal application, then vendor, and then public. And those vendors will need apps for our internal apps. How would we approach that?
So the vendors are like outsourced employee groups, or?
like ISV apps, basically, yeah.
You know,
So, I
started.
mean, I'll start, and you guys can add, but basically, you can do this in one cluster, and a lot of customers who've been with OpenShift since the beginning of Kube, that's what they did, right? They started with one cluster, they did a lot of multi-tenancy within the cluster, and, you know, all the features, namespaces and quota and network namespace
Policies.
isolation, policies, like, all that's in there so that you can keep those three classes of applications totally segregated. When you're doing an ISV app, like the software is already built, right? It's coming to you in containerized form. You just need to deploy it. So at that point, you really just need essentially the Kubernetes runtime, you know, Kubernetes engine we call it, and so forth. So in those namespaces is basically just deploy and run. On the other two, the internal or the public apps, public cloud-facing apps, you know, that'll depend on, you know, how much development are you doing and how much development is your team doing on OpenShift versus you know, outside and so forth. So you can deploy different, yeah. So there's, you know, the operators that you might expose, you know, kind of will be based around that, right? Like, so if you're deploying a lot of you know, if you're running pipelines or GitOps processes in the cluster, you know, you're deploying those operators. If you're not, if it's completely external, then it's almost like you're an internal ISV type use case and so forth. So, but anyway, you can segregate the workloads away from each other, and then it's more like the experience that you want to deliver to the users building or just deploying those workloads. Obviously, if it's for the public cloud ones, we'd love you to use the public cloud service. That could be, you know, I know it's an additional cluster, but it's one that we're managing. So, you know, obviously we have that across the public clouds. I don't know if you guys.
Yeah, I mean, the thing I would add is I wouldn't worry about the compute level isolation, right? Combination of the SCCs, the security context constraints that we have, SE Linux means I'm not worried about an escape from the ISV application into your applications. Then you've. Yeah, I'm going to say, so then just. Exactly, yeah, exactly. So then I was going to come to that. Then you've got obviously the RBAC within Kubernetes, but then the network policies, right? You know, so you can define the rules about which namespaces can talk to which other namespaces, right? So that level of isolation, so you have rules where they can go. The next level, dependent on the sophistication application, could be Istio, right? And those kind of the routing and policies there.
Yeah.
It's something that, I mean, that maybe come to the booth, come to us, we can help connect you with the right architects, but you know, we trust the boundary, container boundary that we have. We have the tools, both upstream Kubernetes and what we've extended with OpenShift to give you that level of isolation, and we can double-click into that.
I would say on the network front, there's probably 3 steps. The first is Kubernetes network policy, which isn't specific to OpenShift. It's everybody's Kubernetes. And you can, like Andy said, you can design it so you control which namespaces talk, but you can also say which pods are allowed to initiate traffic with another pod. So you can get really granular on that control. If that's not enough, there's node-level firewalling or ingress firewalling, which is now available from 4.11 and higher. So you can incorporate that plus the microsegmentation. If that's not enough, then you can go to HyperShift and with those
service mesh even before that, right? So,
oh yeah, so another way is to put Istio down on top of the cluster and really get into the mutual TLS of who's allowed to. Okay.
Service mesh is part of the OCP subscription.
But it's not part of the services engagement, maybe?
Yeah.
Well, I mean, I would reopen up that conversation, quite honestly.
Yeah.
Right? I mean, it may be that they consider that to be overkill, right? And it may be, right? Sometimes you just lock the door once, you don't have to put, you know, a deadbolt on as well. But yeah.
Mm-hmm.
Yeah, there's, I mean, the only operator for F5 is from F5 themselves. I think, Yeah, I think that the choice that I think they're vocalizing is you can go from the load balancer into the service API, or you can go from the F5 to our HA proxy, which is our ingress controller. I think what they're saying is don't go to the HA proxy, maybe.
But I would talk to F5. Both are valid approaches, right? We've had customers running F5 global load balancers in front of OpenShift since pre-Kubernetes, pre-Docker, and so forth. So that's a very common pattern. But as Mike said, the operator for our HA proxy ingress integration would bring traffic through through essentially our HA proxy routes API, or direct to the service would be the other alternative. On the Red Hat side, we're sort of indifferent. Like either could work and stuff. It's more a decision maybe to talk to F5 and then your network administrators about it and stuff, because they own sort of both sides of the integration. I think they're actually here on the show floor. Yeah. How many people have F5s integrated with their OpenShift clusters today? All right, so you can also. So it's a lot, right? It's a very common pattern. So.
No. Okay. I mean, so F5, they have those global rules. I think they call them GLSs or something. They do have integrations where you declare a URL or a route on your pod, and you also want that URL declared on another cluster. And the only way to do that is through the F5 load balancer. And so they do have an ability to watch for things happening in the cluster, but it's them watching. You don't want to be telling.
Here, and then we'll go in the back. Yeah, go ahead.
Another OVN question. I wonder if you guys are doing load testing that is related to the number of ACLs that are in a cluster when you're performing an upgrade. We've run into a situation where we were doing a Z-Stream upgrade, so we were like, oh, it should be relatively chill, no bad things, and it ended up containing an ACL migration, and we have a lot of ACLs in our cluster, and it actually timed out in the middle of the upgrade, and we had to rebuild our northbound southbound database.
Where, and was this on, what version were you on?
This was 410.
410.
410.50 to 410.500.
So we've done a lot. Mike's been painfully aware. Yeah, the OVN
Yeah.
scale and performance work. You want to talk about that?
And Andy's been a part of it too, because we were doing it for his team.
Okay.
But yeah, we've really tackled OVN quite a bit on its scale and performance in the range from 4.11 and 4.12 and 4.13. That's where you're going to see the biggest scale improvements in that database that you're referring to, the embedded OVN open flow rule calls. We actually publish our testing in a doc that all your field reps have access to. So you can see, very specific granular test information. So if you can reach out to your local rep, and we can definitely get you that.
The performance is, I apologize, the challenges on 410, but like it's the results are pretty impressive where they've been able to get to. Last I saw was at 412. I know they retuned and tested again for 413, and I know a lot of that was for the hosted services as well, right?
Yeah, so I mean, the numbers that I have at the top of my head is the number of nodes and the number of ACLs. But I mean, again, as Mike said, if you can share with field rep, we can share that with you. I'd be curious to know what that number is. If you want to drop me your card or something, a contact right after this, I'd like to chase it down.
In the back? Yes. Yeah. So this is a great question about API management, getting it more integrated into Kubernetes, into the cluster itself. So Mike knows the story as well. We kicked off an effort more than a year ago now called Project Compass. But essentially it was the bringing together our API management team that works on 3-scale, our service mesh team that works on Istio, and our ingress team that works on ingress and routes. And because they're just all related to application networking at the end of the day, right? And if you think about those are all layer 7. Just Ingress uses HA proxy, 3Scale uses Nginx, and Service Mesh uses Envoy. What we're seeing in the cloud native community is Envoy is winning, right? Like the cloud native community is really centering around Envoy, and we see this obviously through the continued growth of Istio, but also through something called the Kubernetes Gateway API, right? So Kubernetes Gateway API is a project that's been moving in the upstream for a while to get Envoy as an Envoy-based ingress to the cluster. The implementation of Envoy that we're going to use is the one that comes from Istio. And so right there, that's going to give you another option. So routes is not going away. Same answer as OVS to OVN. So routes has been around for a while. It'll be here till probably I retire. but you'll have a new Envoy-based ingress option probably in the first half of next year because we're waiting for that to get to stable. Now, 3Scale is also going to then work with that Envoy ingress, and there's a new project there called Quadrant, which is essentially taking the control plane for Istio, for 3Scale, and bringing it to work with Envoy. So the idea is that you'd have a common data plane based on Envoy for ingress, mesh, and API management, and kind of a common control plane where whether you're doing API management policies, Istio control policies, or even, I don't know, maybe eventually ingress, egress type policies would come together. But so that's sort of our strategy. I think the next big thing is the release of is Gateway API going to stable and coming into OpenShift. I think that's still first half.
Yeah, that Quadrant team has taken the Istio proxy, the Envoy from that open source project, and they built Quadrant on top of that. So that's also completed in the journey.
So that's our strategy is common data plane, common control plane in this new application networking solution that would serve both ingress traffic into the cluster, east-west, TLS certification, management of the service backplane, and then API management policies without having to deploy, Nginx on top of HA proxy and then off to the side. So that's sort of where we're going. There's one more project that we announced this week, which was called Application Interconnect. That's based on something called Scupper.io. That's solving application networking across clusters, but it also fits into this sort of layer 7 application networking space. So that right now is actually the furthest ahead. So that's GA now. If you want to check it out for networking connectivity across cluster, you can do that. Ingress and then the continued evolution of Istio and 3Scale. That's where sort of it's all coming together. So,
I think there's a lady there. Yes.
Good.
Yeah, Citrix, if you go to our Operator Hub, if you go to operatorhub.io, if you go to our catalog.redhat.com, and you type in Citrix, you'll see an operator for the Citrix NetScaler. I was just talking to a customer earlier today in the CBC that uses it. Yeah.
So, we have that. And, good chance that, if it's common data center gear, we've seen it. Just check it out on Operator Hub. You can reach out either to Red Hat or the Citrix reps if you need more info, but that should not be an issue. In the back.
I'm Craig Wilcox. I'm with the IBM storage team for data foundation.
Okay.
Mm-hmm.
So I'm going to be in the front next to the summit screen at the end because there's a few questions.
Yeah, okay, cool. Yep. Yeah, so you had the ODF question. He can answer it. I was going to try to connect him with Brent Compton and team after, but yeah, there was a question around NVMe and layer storage. So cool. Thank you. Question?
I just have a question kind of in relation to that earlier conversation.
Sure.
Isolation in the form of network policy objects, node firewalling, and service mesh.
Yeah.
Sandbox containers.
So that's more at the compute level. The three-step dance that Mike talked about, that's levels of network isolation for the traffic. On the compute side, like we feel very strongly, containers are a secure boundary, right? And the combination of it's more than just C groups and namespaces. It's SC Linux integration, which we have turned on by default. It's seccomp policies and so forth. So, just standard containers are a great compute boundary. Now, we do now also support Kata. Kata is sort of a micro VM type technology. It's based on KVM. Comes from our Vert team and so forth. So if you want another level, right? Essentially, your pods are sort of micro VMs, similar to the Firecracker from Amazon, and there's other sort of approaches to this. You can do that. It'll be another layer of isolation on the compute side. The trade-off is basically it's heavier, right? It's not pods, and I think you have to run on bare metal, right?
You just changed that. I was going to mention that. So it's in tech preview, but it's called peer podding. So typically with Kata and any KVM, you have to get bare metal. You can't sit on top of a EC2 instance because it's already virtualized. There's now something called peer pods where we will call an API and we'll manipulate what we want that VM to look like on the EC2 instance.
Yeah.
So it's check it out. It's in the documentation.
Yeah.
I mean, you pay a price for overhead, there's network complexity, but if you're in a high-risk environment where with untrusted workloads, then it's the next level of safety. Right?
Yeah.
If I was running a cloud hosting provider with that kind of attack surface, then it would be something I would look at. Yeah. But running something, my own workloads, it would be, I think there's a lot of overhead there.
Yeah.
Extra security when you need it.
Yeah, I think some people jump to Kata and micro VMs too quickly, and it's like you're going to pay a penalty in the overhead because essentially we did containers to get away from VMs. Yes, we can bring them back in these micro VM formats, but anyway, it's in the product. Check it out, and then it looks like there's some new technology for nested on top of other Vert. So we're definitely evolving that. Any other questions? In the front. Control plane.
You wouldn't need it in HyperShift because the control planes are pods, but they are supported in standalone or classic. As of 4.13, it went GA.
What was it? Control plane.
Machine sets.
Oh, machine sets.
Yeah. So now your machine sets can control and watch over your control plane. So if one of your 3 nodes goes down, you can have a machine set add that particular node back in.
It's a feature that Andy waited for a very long time.
But the beauty of with HyperShift is, it's just pods. The control plane is pods.
Yeah.
The way it's scaled, its resilience is just fundamental Kubernetes. So it's not relevant, and you get very flexible scalability with HyperShift.
Yeah.
Yeah. So because we've always had machine sets for the worker nodes. 4.13 is the machine sets for control plane VMs. And then, like I said, HyperShift, since the control planes, we turned them into pods. Now you can just use standard Kubernetes, scale, and restarts and stuff to manage those. You don't,
Still 3. Yeah.
I think we probably have time for one more. Anybody want to take the last question? All right, we've exhausted all our questions. Good. Well, oh, actually, I didn't see you. Go ahead. Yeah.
I'll ask you something different.
Yeah.
My company is starting to get into OpenShift.
Yeah.
We're not using it yet for custom apps, but we will.
Yep.
And so I work in the dev organization. I'm kind of trying to find the right way to introduce this to our devs because we're a cloud foundry shop today. So devs basically sticks it in fire and they forget. They don't see any of it, right? And so do y'all have any general work on how to kind of
So we're getting a lot of experience migrating Cloud Foundry customers over to Kubernetes because of the uncertain future there on the PCF side. So we've always had a PaaS abstraction layer in OpenShift where you could do things like deploy app. Yeah, OC new app, source to images, the underlying technology, different layers. We have the OC CLI on top of kubectl. We have ODO, which is a higher level CLI that was literally mapped to
CF push.
to CF push. And then we also now, I think, we support Kubernetes build packs, which is sort of bringing the PCF build pack. So there's a lot, and then Backstage takes abstraction to sort of another level in terms of IDPs and so forth. So what we'd love to do is, if you have a PCF user, don't assume that you can't get that same experience in OpenShift, because I think you can or you can get pretty close. We also have the more the CAS experience, right? So we used to get attacked from both sides, right? When we were going against sort of pure kube solutions, they'd be like, oh, OpenShift, that's just a PaaS, it's not real Kubernetes. And like, no, it's Kubernetes compliant. You can use it from kubectl, you can use all the objects and so forth. So we have that experience if you want just straight up CAS, Kubernetes, kubectl. But we do have a lot of features and an entire team that just works on abstractions like what I mentioned, and then new stuff like Backstage and things like pipelines and GitOps and so forth. I think it's...
Yeah.
Yeah.
So the best is a multi-pronged approach that I see successful. So the first thing that people kind of fall down on is they'll look at apps and they'll try to pick which apps will move first. But what you got to do is you look at the people and you look at what people are going to be successful. And then you pick those teams and you expose to them the full breadth of that developer experience. As they're experiencing that, the teams that you didn't think would be successful, change them without them knowing. Like just when they do their thing through their pipelines, unbeknownst to them, it hits an OpenShift at the end of that target. They don't have to know anything.
Yeah. So we have customers like they've built such abstractions. The developers don't even know they're using OpenShift or Kubernetes, and those are hugely successful because you're just really tied into the development workflow. I talked to a customer actually at this event, and I thought it was the experience, and it turns out what they were doing in PCF was fire and forget, but it was the developer that was forgetting. There was an operations person that was coming in when there was issues, scaling or performance issues in prod, like fixing stuff. So it was more like they're putting stricter policies in place on the move to OpenShift, but it's less to do with the interfaces and more to do with them trying to get more rigor and more of like a DevOps approach. I won't say who it was. Some insurance company. But seriously, I think we have a lot of experience going all the way back. We've been competing with Cloud Foundry since I started. We started OpenShift 1 12 years. So we know a lot about how to map the interface. Yeah. Okay. Cool. Yeah. No, we're totally committed to sort of continue to build out that PaaS layer of abstraction. The announcements that we made here at Summit hopefully are a good indication of that. And then also committed to being the best Kubernetes platform that will run in any environment. So I want to thank you all for coming. I know there's another session coming in. I really appreciate it.
Thank you.
Great. And thanks for being